So today, lesson 2, descriptive statistics. In research, you collect data. Next, how to describe the data. So we start from data being collected and how the process goes from step by step, right? Okay, so collect data, whatever data interested in, example, depression value, depression among dialysis patients. So you want to know what's the average depression. You want to measure performance of students. So take the marks of the students and then you describe it, information, describe it. After that, next lesson onwards, you go into facts, testing, by estimating, and so on. Just a minute, another call is coming. Okay. Okay, so that's what I'm going to do today. So today's class will be information, describing the data. After that, we go into other areas. Okay, anybody waiting?
Hello, Professor. We have some classmates waiting outside.
Yeah, okay. Okay. So that's what we're going to do today. How to describe the data, right? So remember, data can be quantitative or qualitative. For example, we discussed it last week. This is my population. For the population, we take a sample. Why not study the entire population? Because of ETC, energy, time, and cost. So resort to taking a sample. So here, let's say you want to study a variable X. What's variable? What is a variable? Can somebody explain what is a variable? Last week we discussed. Anyone? What is a variable? Linda, what's a variable?
It is a factor that we can change.
No, not a factor. What else? What's a variable?
Such as time, temperature, pH,
Okay,
etc.
define. Okay, define. Give me definition of variable. What's a variable? Just like I give the notes, a characteristic of interest. Characteristic of interest. That takes different values in different items, objects. Example, is weight a variable? Is weight a variable? Mansha, is weight a variable?
Yes, it is,
Why this is a variable?
because it can be changed.
Not changed. Different people have different weights, right?
Yes,
The weight differ from person to person, not changed. Weight can differ from person to person. Right. Marks obtained by students. Is it a variable? Fun is marks obtained in an exam. Is it a variable? Fun, not there. Tong,
yes,
is it a variable?
yes.
Marks,
Yeah, so
Hello.
Yeah. is
Yeah, I
marks
think
a-
variable.
Why do you say it's a variable? Why do you say marks is a variable? This is a very important concept to all.
Everybody has a different marks.
Right. The marks differ between the students.
Yes.
One person having 90, another person 70. So that's a variable. Right? For example, we're interested in the students they're taking a particular exam. You want to measure the marks. Right? So what do? We take a subset, we call it sample. Let's say there are 1,000 students set for the exam. We take 100 students. So that is population to sample. We are measuring something, right? Another example, let's say you want to know population, let's say factory workers. We are interested in studying the blood pressure. Blood pressure is a variable because different people have different blood pressure values. So again, we can't study the entire population because of ETC, energy, time, and cost. We take a sample. So that is sampling we done last week, right? So once you have the sample, first step is to describe the sample value. Select a sample, say size n, measure the values, example, height, weight, BMI, and so on. Next, describe the characteristics. The variables can be quantitative or qualitative. So quantitative variable we describe in terms of mean, median, standard deviation, other things. Example for weight. For qualitative variables, example hypertension, yes, no. Certain pass or fail. They are qualitative data. So we do frequencies and proportion. So first, we're going to learn how to describe a quantitative data, quantitative variable, right? There are several measures. One is measure of central tendency, where is the data centered. Second is measure dispersion, how the data are spread. Are they close? Are they spread? Next, we study skewness. Is the data symmetrical or asymmetrical? Next, we talk about identifying extreme values and outliers using the box plot. Next, we study normal distribution. So given a data set, you're going to describe in terms of the 5 things. 1, where's the data centered? 2, how the data spread. 3, is the data symmetrical or not? Are there any outliers or extreme values? And finally, is the data distributed normal? Many analysis or tests require this assumption, right? Therefore, you must know how to test this. Let's go back to number 1. Central tendency. Mean, symbol X bar. Median, symbol M. We won't talk about mode. So mean, X bar, M is median. So what's mean? Arithmetic average. Add all the numbers and divide by the number of cases. It's quite sensitive to outliers. We see an example afterwards. Median. We arrange the data, let's say from lowest to highest. Take the center. That center divide the half into 50th percentile. From the center, let's say 30, 50% of the cases above 30, another 50% below the 30. That's how you express median, right? So it's not sensitive to outliers or extreme values. Look at the example. Number 1, 2, 3, 4, 5. So what's average or mean? Average or mean. We add all the numbers and divide by 5 because it added 5 numbers. Answer is 15 over 5. That's 3. Median. We arrange the data in order, ascending and descending. Take the center. This is the center. Right? Cut this off. Cut this off. Cut this off. Cut this off. So this remains. Now I can see mean and median are the same place. Same location, mean and median. So you can say the data is symmetrical. Why study mean and median? Data is symmetrical. Right? This and this are similar, symmetrical. Later we see what is symmetry means. Next data set 1, 2, 3, 4, and 5,000. So if I do the mean, add all, divide by 5. The answer is 102. A median, chop this, chop this, chop this, and chop this. The median still 3. Now look at the difference, median and mean. The median and mean are very far apart. That is, a data is not symmetrical. So mean and median can be used to assess, not to check, to assess whether data is symmetrical or not. Where the data is not symmetrical, no point using mean. Use median. The data is symmetrical, doesn't matter which one you use. Most of the time, use a mean. Then, the data is symmetrical, we use mean. Data is not symmetrical, we use median. Right? Just to describe data. Next, dispersion. So time being, just look at this. Dispersion. All of you, put up your right hand. Put up your right hand. All of you, put up your right hand. Close all the fingers. Make the fingers very close to each other. Now open the fingers. Make it wide. So what is dispersion? That is dispersion. When you make your fingers close together, very small variation, dispersion. When you make the fingers very far apart, so you can see big dispersion. So what's dispersion?
你会计也只要考169分啊。
Is that
金
essentially
融在哪里啊？
300多分嘛。
啊，338。
对，就是那个老高了。
essentially the gaps between the fingers. When you open the fingers, big gaps, big dispersion. When you close the fingers, small gap, small dispersion. So what is dispersion? Measure of, what is standard deviation? Is one measure of dispersion. All these are measure of dispersion. Time being, we're going to go into this. Standard deviation. Big value means big dispersion. Small value means small dispersion. Right? Example. Look at example 1, 2, 3, 4, 5. I will skip this. The standard deviation is 1.56. These are done step by step. I don't have to know all this because later we use SPSS, put the data in, click some buttons, we'll know what is standard deviation. So for this data set, the mean is 3, center, and the spread, how much difference between the data point is 1.56. So it will be expressed as 3 plus or minus 1.56. We'll do more detail later. Right? Skewness. Skewness, data is symmetrical. Symmetry means what? I cut here, I get equal halves. That's symmetry. Where shall I cut to get equal halves? There's no symmetry. Here also no symmetry. Symmetry means I cut here, I get two equal halves. So symmetry measure, skewness is a measure of symmetry. Skewness is a measure of symmetry. I've given three different formula. This is the exact formula that software has used. This is an approximate formula given to understand the meaning. So look at this formula. It's function of x bar and m. When the x bar and m are equal, example, x bar is 20, m also 20, 20 minus 20, this is going to be 0. So when it's 0, we have symmetrical. When x bar and m are equal, this value is 0. 0 means data is perfectly symmetrical. So what are you using here? X bar, m, and standard deviation. Look at the next one. When x bar is very much bigger than m, let's say x bar is 100, m is 30, 100 minus 30 will be very big, positive. So we say positively skewed data. When x bar mean is more than median. The third one, let's say x bar is 20, m is 40. 20 minus 40 is negative. I'm not telling what number because must use others too. It's negative. So data will be skewed to the left. So generally later, the procedure SPSS, we ask for a value. It'll give a number, right, to indicate the skewness. Any values within plus or minus 1, right? You can start from 0, you can go to very high value, also very low negatives. So if the value is 0, perfectly symmetrical. If the value is within plus or minus 1, that means between minus 1 and plus 1, then the data can be assumed symmetrical. We don't expect perfect 0. Symmetrical means these two are not very far apart. Asymmetrical means these two are very far apart to the positive or to the negative, right? So that is skewness. Example, using this formula, the mean is 3, right? The mean is 3, median also 3. So 3 minus 3, skewness will be 0. That means perfectly symmetrical. Our second example just now, the mean is 102, the median is 3. So mean minus median is very positive. Then the data will be skewed to the right. So when the mean and median are similar, data are symmetrical. The mean and median are very far apart. This data will be asymmetrical. You can see from this formula, right? Any questions so far? Next, box plot. So what does box plot do? There's a box here, and we call it whisker. Whisker, mustache. Whisker here and whisker here. So what's a box plot do? It segments the data into 4 quarters. That means 25% here, 25% inside here, 25% inside here, and 25% over there. So from 0 until 25%. So this value is called first quartile, Q1 or 25th percentile. Go another 25%. So covered from here to here 50%, right? Also called Q2 is also a median because 50% is covered here. Another 50% covered over there. So that midpoint is called median, also called Q2. From here to here is another 25%. So 50 plus 25, 75th percentile. also known as Q3. The distance between Q3 and Q1, this is called interquartile range. In other words, what are the limits to capture 50% of the cases? That's interquartile range. Now the outliers, when the figure output comes in, when you see a circle beyond the whisker, that means an outlier. Outlier can still be part of this population. It can be above or below the box plot. We see an asterisk sign, then that value, extreme value, may not belong to this population. May not belong, right? Maybe above or below. Data will see data set, right? And see how to interpret values. Again, what's box plot? Segments the data into 4 quarters. The box contains 50% of the values. The difference between Q3 and Q1, also known as the interquartile range. The median is also known as a Q2. So that's box plot. Normal distribution. Characteristics. Basically 3 characteristics. Number 1, it must be symmetrical. Here you see, if I cut along this line, the part on the right and the left will be equal. So this is symmetrical. Next, symmetrical not enough, it is bell shape. Even a box can be symmetrical. Box, cut the center, box can be symmetrical. A circle can be symmetrical. But second condition is that beyond symmetry, it must be bell-shaped. So this diagram is bell-shaped because you tie a bell here and can ring, ding, dong, right? That's a bell shape. Still not enough. Third condition, area under the curve. So this is symbol for mean, this symbol for standard deviation. Mean and standard deviation. So mean is center. From here, walk 1 standard deviation. That will be mean plus 1 standard deviation, 2 standard deviations, and 3 standard deviations to the right. Similarly, -1 standard deviation, -2, and -3. Right? So it's really normally distributed between the green lines, plus or minus 1 standard deviation. The area under the curve must be roughly 68%. 2 standard deviations between the purple lines. This area must be roughly 95%. Plus or minus 3 standard deviation, red dot, from here to here, must be approximately 100%. So how do you know a given data is normally distributed? It must have these characteristics, right? So we can see these two, whether symmetrical, bell shape, but this we generally calculated, let's say using the software, right? Can't be counting each one. So later we'll see how do you know these conditions, 3 conditions are met, right? A single value will tell you. An example, let's say marks in exam, mean 50, standard deviation is 5. But mean is the center, 5 standard deviation is a dispersion. So this is a case, center 50, plus 5, 55, minus 5, 45. So plus or minus 1 standard deviation, right? So 45 to 55. This area will be roughly 60%. which means 68% of the students' marks will be between 45 to 55. Then go to two standard deviations, 55, 60. So that is two standard deviations. Over here, two standard deviations. So between 40 to 60, 40 to 60, roughly 95% of students. Three standard deviations. 1, 2, 3, and 1, 2, 3. Almost 100% of the students' marks will be between 45 to 65. All right? Questions? Questions? Okay, I have a question. What are chances of student getting 80%, 80 marks? If this is the condition now, the distribution, what are chances of a student get 80 marks? 80 marks? 10? 10. How come most of you are not here? Han? 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 I'm going to ask you on your camera all the time. On your camera all the time. All of you on your cameras. Turn on the cameras. All of you. Not many yet. Where is Fun? Where is Zhao? Tell your friends for next class onwards, I'm going to check every time whether you're on. If you're not on, that day you're considered absent. Right? There's no point come to class on your Zoom and then go off. Right? So many are not here. All right. Among those who are here, Han Yongking. Han, are you there?
Yes.
Okay,
Professor.
answer the question. What are chances of a student getting 80 marks? What are chances of a student getting 80 marks?
Pardon, please.
What's the last one say? Read this one. Read. What's the last statement says here?
I think it's 0.
What is the last one says? Almost 100% of the students' marks will be between 35 and 65, right?
Yes.
65 is here, right?
Yes.
Yeah, no 80.
Where's 80?
No.
You can't say no. 80 somewhere here, right?
Yeah. Extreme to the extreme.
Is it outside the curve, isn't it?
Yeah.
They all fall here 100%. You are sitting here. So chance 80 is 0, almost 0.
0. Yeah.
Supposing 80 and above is A. More than 80 is A, grade A. Mansha, what's the chances of getting A?
I'm not sure, sir.
80 and above, I give you A. This from 35 to 65, right? Mansha? What are chances of going here? It's already
I'm not
coming
sure.
almost flat, right?
Yeah.
Actually, this is a frequency. 50%, that's frequency. And the frequency coming down, and almost flat. That means no more. We say to get A, to get 80, where's 80 now? 80 must be here, right? Is it outside the norm?
Yes.
Is it outside?
Yes, it is.
So what's the chances of getting A?
Mm.
0.
Almost zero. Almost zero. Supposing to pass, you must get 50%. 50%. Jiang, what are chances you passing? 50 and above, you pass. What are chances you passing? Jiang? Jiang, which end?
Yes, here.
More than 50, you pass. What are chances you passing?
I'm not sure.
This 50, right? Is it right?
Mhm.
This side means you pass, right?
50%.
Yes.
This side means you fail, right?
Oh, yeah.
So what's the area from here all the way? What's the area?
Right, Ariel.
How much?
How much? 50.
50%, right?
Yeah, 50%.
Oh.
This side 50%. This side 50%. So
50%.
say 50 and above A, your chance is 50%, right?
Mm.
Right? That's why this particular graph, the normal distribution, is very important in almost all industries. Agriculture, shoe production, manufacturing, right? All are using medical. In medical area, extensively used. Example, temperature. 39 degrees means what? Again, based on this, we say 39 degrees means what? So this table, this particular distribution is very important and it's extensively used. Now, standard normal curve. So what does it do? Look at the 50 and 5. It transforms to 0 and 1, right? 0 and 1. So 50 becomes 0, 1 standard deviation, 2 and 3. On the other side, -1, -2, -3. Standard deviation is 1. So 1 standard deviation to the right, 2 and 3, center 0. So most of the calculation we're going to do later will be based on standard normal curve. How to obtain from this table? Most of our statistical distribution table will have this books, statistical books, will have this table. But nowadays, we can use softwares like Excel to compute this. Later in the analysis, let's say I want to test whether the mean marks is 70. Results will come in terms of these numbers. And you must be able to interpret that. Right? Okay, that's our focus going to be. I want to skip this. Okay, so what's the normal distribution? Symmetrical, bell shape, and the area under the curve, governed by mean and standard deviation. So I give an example. Mean is 50, standard deviation is 5. So what does it mean, students' marks? Whole 100% will be between 35 to 65. You're asking about 80, none there. Young? Young, Yanan? Young? If below 35, you fail. Below 35, you fail. What are chances you failing? Below 35, you fail. What are chances you failing?
Do you ask me question?
Yeah, ask you a question.
Oh, my name is Wang Yanan. Wang Yanan.
Oh, okay. If the mark is below 30, you fail.
Below 30?
30. That is 30 here.
Yeah, 0.
Somewhere here?
Yeah.
0.
0.
0.
Right? I mean,
Yeah.
in between, be very difficult to interpret, understand, but you must know what the extreme. 80, 0, 20, 0. In between, you must use this table. You don't want to go into that, okay? That's distribution. I'll skip this, right? Example, body temperature. Let's say from studies, from data, we obtain the mean body temperature is 37. That is standard deviation. 37, 0.3 standard deviation. Let's count. 37 plus 0.3 plus 0.3 plus 0.3. Supposing a person's temperature is 39 degrees. Is it normal? Since temperature 39 degrees. Is it normal?
No.
Where is 39 degrees? Somewhere here, right?
Yeah.
Not normal. All this came from where? Came from statistics. We convert to a standard normal distribution. Use this formula. Remember, the mean is 37. That's the standard deviation. Just understand this, okay? Just understand. 37 minus 37, that is 0. 37.3 minus 37, 0.3
3.
divided by 0.3 is 1.
That's 1.
37.6 minus 37 divided by 0.3, that's 2, and so on. Same thing on the negative side. So why is it useful? To check whether temperature is normal, to check whether BP is normal, whether blood sugar is normal. So this table, this particular distribution, heavily used in almost every field. So you can't run away without this. Again, some of the analysis require the data to be normally distributed. Again, you must know how to check and report. All right. So whatever you did just now, let's go put in practice. First, you want to know where's the data center. Next, you want to know how the distribution is. Next, you want to know data is it skewed or symmetrical. Next, are they extreme values or outliers? And the last, the data is it normally distributed. Okay, let's see the example first. Right. The data I already sent you just now to describe systolic blood pressure. Systolic blood pressure, right? Okay. This is the data. It's a data file. The systolic blood pressure is variable number 11. So you want to check this systolic blood pressure. Right. Okay, this one I'm going to do step by step. The yellow box, you open out SPSS later, you follow exactly what is shown here. The first 3, this pop-up will open up. And SBP move inside this box. And then click plots. This pop-up open up. You check this box normality. That's all I'm going to do. Let's look at the results. There's so many values here. First, what's a mean? Mean is
Average.
average. 1 to
100
8.
and
All right, that's a mean.
1 to 8.
What is standard deviation? 15.89.
15.89.
So that's mean, that is standard deviation. Right? Next, median. That's a median. Median is 1 to 9.5. Means what? Cut at 1 to 9.5. 50% of the participants will be more than this. 50% more than this. Another 50% will be less than that. Right? So either can use more or less. Don't use both. Don't use both. Skewness. So what's the skewness value? Is it within plus or minus 1? Is it less than 1?
Yeah.
Yes,
Yes.
plus or minus 1. Therefore, data can be assumed to be symmetrical. See what we talked about earlier. We want to know where's the data centered, right? We have the mean and median. How the data spread. We have the standard deviation. How the skewness, the value is within plus or minus 1. It can be said data is symmetrical. And then normality, right? Sorry, so far only this, 3. So far, mean, median, central tendency, dispersion, standard deviation, and skewness. Right? So all these came from that one table. This table. Mean plus or minus standard deviation. That's median. And that is skewness. So no more calculation. You must know what to click and what to look for and how to write it. Next, look at the histogram. Okay, box plot. Are there any circles, extreme signs beyond this or below this? Are there any circles? Come on, participate. Are there any circles?
No.
No. Are there any asterisk signs? Asterisk sign. Maybe I'll let you compare this. Okay. Are there any circles? Are there any asterisk signs?
Yes.
Right. So circles are outliers. These are extreme values. But in our example just now, are there any circles or extreme values?
No.
No. So we say the box plot, there are no outliers or extreme values.
Extremely value.
Right? So we covered this part. Right? We don't have this. We don't have this. There's no outliers or extreme values. And the last one, is it normally distributed? Later, we have this table output. Right? There are 2 tests. We can see one test is Kolmogorov-Smirnov, KS. Another test, Skewness, SW. Which test you use depends on sample size. The DF is a sample size here. If the DF is more than 50, we say large sample. DF less than 50, we say is a small sample. Large sample use KS. In our case, 108, which is more than 50, we use Kolmogorov-Smirnov. Less than 50, we use Skewness. Then what do you look for inside the table? We look at the SIG value. The SIG value is also known as P value. Right, the P value.
Yeah, P-value, significance.
So don't say SIG value, just say P value. It's understood.
P.
If the P value is less than 0.05, it's a mistake here. This must be, correct. Not normal, right? It's right. Okay. If the P value is less than, okay, we follow this. We check this P value. If it's less than 0.05, we say not normal. So in this test now, our sample size is more than 50. So we're going to refer to KS. So in KS, if the P value is less than equals to 0.05, we say data is not distributed normal. The other example, what is this value? Is it more than or less than 0.05?
More than.
More than 0.05. Therefore, can be assumed to be normal.
Distributed normal.
Normal. Right? Depends which test. First test, big sample size. Second test, small sample size. We look at the same cut point in the SIG or the p-value. Big sample, this value. Small sample, this value. So using this value, more than 0.05, conclusion, data distribution can be considered normal. Because that's normality. So whatever 5 points we discussed, we know how to evaluate it. Point summary. Number 1, mean, plus or minus standard deviation. Number 2, median. And what does it mean? Number 3, skewness. Is it within plus or minus 1? Yes. Can be assumed symmetrical. The box plot, no outlier extreme values. Normality, p-value was more than 0.05. Data can be assumed to be distributed normal. So all the 5-point summary they're getting from this output. Here we take mean, standard deviation, and skewness. From this, you can see no outliers or extreme values. And from here, you can see data can be distributed normal. Okay, that's 5-point summary. From this, you understand where is the data located, mean, center located, how it's spread. 50% of the cases where they fall, symmetrical, asymmetrical, any outliers, extreme values, and is it normally distributed? Let's see another example. TG for triglyceride. Triglyceride. The mean, that's a mean, and that's a standard deviation. So we write 2.78 plus or minus 1.76. Median, that's a median.
2.19.
At least 50% of the participants TG is more than 200. Skewness, 1.915. Is it more than 1?
Yes. More
That
than
means data is not symmetrical.
not
It is
symmetrical.
skewed to the right. Not symmetrical, since positive, skewed to the right. So when data is not symmetrical, it's better to use median and IQR in the summary. Median and IQR. So that's a median. IQR, interquartile range, that's IQR. Right? This is not very accurate because data is skewed. This is more representative median and IQR. Okay. Next, you can see many, these are the cases, case number 37, 70, 106 in a file. So there are 3 extreme values. With the values are about 9. 3 extreme values in these case numbers, with the values of about 9. Yeah. And there are several outliers. These are the outliers. Values between 6 to 8. Right? Next. Normal. Sample size more than 50. Big sample. Homograph similar. So look at this value. Remember, when SPSS reports 0.000, you interpret as less than 0.001. Don't say 0. It's a truncated value. It could have been 0.000758. So 3 decimals, say this. Is this less than 0.05?
Yes.
Yes, obviously less than 0.05. You don't have to say less than 0.001, which is less than 0.05. Obvious, you don't have to say that. So p-value less than 0.001, hence data is not distributed normal. We can see here, skewed to the right. Right? So the 5-point summary put together: mean and standard deviation, median. What does it mean? Skewness more than one, data skewed to the right, not symmetrical. And there are extreme and outliers. The p-value for normality less than 0.001, data is not distributed normal. Okay, now you go to hands-on, and then, right, then talk about this. Okay, open your file sent to you. Open your file, data file 1. Open data file 1. Okay, data set 1. These are the variables.
Yes. ID, age, gender.
Okay, can you all open the data file? Okay. Let's see which data is quantitative, which is qualitative. Age, quantity or quality?
Quality.
Quality.
Quantity, sorry. Quantity.
You can add them, quantity. Gender.
Quality.
So what about others? Quality. Job
Quality.
category.
Quality.
Quality.
All say this. Job category. Quantity or quality?
Nurse.
Quality. Quality.
Okay. Can you add attendant and nurse? Can you add them? Can you add 46 and 31? Can you add? Can you find
Yeah.
average?
Okay.
Okay, what's the average of these two?
What's average? 45?
45 can. What's the average of these two?
No.
Yeah.
Cannot.
Yeah.
So whatever values cannot average, they are qualitative. Variables can average, they are quantitative. Again, age, quantity or quality?
Quantity.
Gender,
Quality.
job,
Quality.
years of service.
Quality.
Quantity,
Quality.
can you add these two?
Yes.
How to add this to become what?
No, it's quality.
It's more than 10 years.
Oh, quality.
It's not ordinal or nominal? Ordinal or nominal?
They
It's a name given, right?
yeah.
Is male better than female?
No.
No, then it's a nominal. What about this?
Yeah.
Ordinal, nominal?
Ordinal.
Ordi, right?
Yeah,
Less
they
than
have
5
order.
years. Order, 5 to 10
Yeah.
years. More than 10 years. This ordinal. Marital, quality or quantity?
Quality.
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 Physical active, okay. Quality, nominal, ordinal?
Nominal.
PA, quantity or quality?
Quality.
Quality, nominal, ordinal?
Nominal.
Why is it nominal? Rarely, regularly, sometimes. That's the difference, right? Rarely,
Yes.
almost zero. Sometimes and regularly. There's an order, right?
This order, there's an order.
Rarely exercise, sometimes exercise, regularly exercise is order, right? You exercise rarely, sometimes, regularly.
Okay. Oh, so
Intensity.
frequency.
Yeah, the intensity is different,
Ah.
isn't it?
So
Right.
that's ordinal.
Ordinal.
Oh.
Okay, DM, hypercholesteremia, hypertension, they're all qualitative. Height,
Quantity.
quantity, weight,
Quantity.
stress,
Quantity.
any average? Then it's quantitative.
Yeah.
Systolic blood pressure,
Yes.
diastolic,
Yeah.
triglyceride, BMI, quantitative.
All quantity.
Right. Obese? Obese?
Quality.
Yes, no, qualitative. MC is medical leave. Medical leave taken. Quantity or quali? Medical leave.
Quality.
Quali because yes, no only.
Yes. Yes.
If I put that
No.
1 day, 2 day, 3 day, 4 day, 5 days, then become quantitative. Type of movie,
Quality.
quali. So here we can see combination of quantity and qualitative data. So first, we're going to describe quantitative data. Right. So can you follow the instruction? Follow
Yes.
the instruction.
Wait.
Okay, that's instruction. And that's your data. So the menu here, menu refers to this. It's a menu. This is a menu. Click analyze. Accept. Descriptive 36. Right? Descriptive 36. Explore. Explore. So analyze, descriptive, explore. Right, that's sequence.
Analyze.
Practice this again because very, very important area. Explore. You can explore what? Which variable? Explore which variable? Which variable?
Height, weight, stress.
Which variable here? The box, yellow box. SBP, right?
Yes. SBP.
SBP, that's
TG.
SBP. Click, select, and click it. So dependent variables SBP. We describe SBP. Next, what do you click? Plots. Click plots. What do you ask for? Normality plot with test. That's all it does. Continue. And cancel. You're going to do all over again. Cancel. Do a few times until you know exactly what to do. Analyze. Descriptive 36. Explore.
No.
Right, we can't see variable. What do you do? Right click your mouse, right click, and select the first button, display variable names. Okay, that comes labels. So now you know which is variable, BP, SBP. Next is plots. For the plots, select normality plot. Continue. and click OK.
Okay.
Okay, compare the results. All right, so that's the table. So here, what do you need? We need the mean plus or minus
Where's the
standard
table?
deviation. Yeah. And then median. And then skewness. There's so many values here. So these are values we obtain here. Here, mean.
Sorry, Prof. I didn't see the graph, the table.
You don't have this table? Let's do okay.
Yeah.
Go to analyze. Descriptive statistics. Explore. Are you there?
Yes.
All right. So this pop out. You
Yeah.
bring SBP
Mm.
inside.
Yeah. Plots.
Plots.
Yeah.
Ask for normality plot. That's all.
Yeah. Continue.
You
Yes.
and click OK.
Okay.
Can you see now?
No.
You can't see mine, is it?
Yeah.
Okay, hold on.
I can't see any table. Yeah.
Okay. Share screen. All right, do you see now?
Okay. Yeah. Yeah.
All right, okay.
Yeah. Descriptive. Yeah.
All right. So that's a mean,
Mhm.
that's standard deviation. That's a median. And that's
Yeah,
your
median. Skewness.
done. Next. Let's go to box plot first. The box plot. Okay, that's a box plot.
Hmm.
Are there any circles, asterisk signs
No.
above or below? No,
No.
right?
No.
There's no extreme or outliers.
No. Extreme.
Let's come to normality. Normality, test of normality. So sample size more than 50.
Yeah.
We
More
take
than
this one.
50.
0.061,
Yeah.
which is more than
It's
0.61.
normal distribution.
Normally distributed.
Normal
So you
distribution.
write the 5-point summary. Okay, 5-point summary. By this, you understand your data. Should not straight away go into analysis without knowing what's the data all about. Okay. Let's do next one. Triglyceride. So same way we do for triglyceride. Analyze
Descriptive statistics.
and explore. So select SBP and take it
TG.
out. And then select TG
TG.
and put it in. That's all.
Mm.
Plots.
All right, plots. You already have the normality plot.
Continue.
New
Good.
and click OK.
Okay.
All right.
Mean. Median.
Okay, that's a mean. I will return here. And that's
American convenience.
median. Mean, right? Mean, that's standard deviation.
Yeah.
That's a median. And this is skewness. More than one,
More than one.
or data is not symmetrical.
Yeah. Screw to
That's
right.
the box plot. In the box plot, you can see so many circles and so many asterisk signs, right?
Yes.
This 34,
Yeah.
70,
Extremes and outliers.
right? The numbers refer to the case number. Example, case number 34. That's the case number. Look at TG. TG, I say very high, 9. Right? So these numbers refers to the case numbers. So the box plot, we are seeing there are several extreme values roughly value 9. Several outliers, they're all between 6 to 8.
7, yeah,
6 to 8, right?
6 to 8.
It can't be exactly 7 because the range, isn't it?
Yeah,
All
between
same
6 to
point.
8.
Same point 9. Right. Finally, the data distributed normal. The data is not symmetrical. It cannot be normal.
Mm.
Right? Now, symmetry.
Yes.
Yeah. So this
No.
p-value is less than 0.001. Obviously, it's
Yeah.
less than 0.05. Therefore, it's not normally distributed.
Distributed.
Yeah. So again, 5-point summary. Any questions? Any questions?
Prof. So if the p-value, yeah, is less than the 0.0001, it's not normally distributed. So what
Yes.
does it refer?
It means
Yeah,
What's
what can
normal
we
distribution?
what can we infer from the data?
what is our definition of normal distribution? Right? Right. First, it's not symmetrical.
Yes.
Second, it's not bell-shaped. This is very important.
Yeah.
So the coverage is not 68, 95, 100%. So this kind of pattern is important for many analysis. So this data does not support this normal distribution. Whereas previously,
Mhm.
this one here supports normal distribution. If yes, most of the time we do parametric test. Parametric test. If comes like this, it's not normally distributed, then we cannot do parametric test. We do non-parametric test. That's a case.
Professor,
Ah.
Yeah.
Oh.
Professor,
Yeah.
I'm having Qing.
Yeah.
Can I ask a question?
Sure.
You mean that the table of the normal distribution is a norm or criteria?
Normal distribution. Normal. Yeah. Say again.
You mean that the table of the normal distribution is a norm?
Yes.
Is it?
Yes.
Oh, I know.
So you have data, you must check all this 5-point summary. Check that.
We can competed other data to this table.
Other data. Yeah. This is standard test.
Yes.
Okay.
Mm.
I give an example. If the,
Other question I want to know that the p-value, if the p-value is less than the 0.005,
is it less than 0?
it's not normal.
0.05?
It's normal.
Okay, hold on. Let me change that.
You mean that in this situation it's normal?
No, it's not.
It's not normal.
Enough. Now, is it normal?
It's not normal.
Is it more than 0.05?
It's normal.
It's normal.
Normal, right? Normal.
Yeah, it's
More than
normal. It's
0.05.
more than 0.005.
Oh,
Is this normal? Is this normal?
No,
Why it's not normal?
in this
it's
situation,
less than
Less than
0.005.
0.05. Less than 0.05. Now another example. Is it
No,
normal?
no.
This is less than 0.001.
Yeah,
Less than 0.001. Is it less than 0.05?
of course.
Of course. So it's not normal. So straight away, When SPS gives this value, straight away we say not normal. Right? Not normal.
Yeah,
Okay.
I know.
Yeah.
Second.
Are you okay?
Okay.
All right. Now, normally all this apply for small sample, but for social sciences, it may be collecting very large sample, sometimes even 300, 400. You can also apply this way to check for normality. That is a literature, okay, according to whom. Right. He suggested calculate Z1 and Z2. So what's Z1? Z1 is skewness over standard error. So where's skewness? This is skewness over standard error. So that is standard error. This divide by this. And then Z2 kurtosis divided by standard error. Z2 is this value. Can somebody calculate this? What's the value for this? This divided by this. Skewness divided by standard error.
Skewness divided by.
What's the value? Okay, this example, huh? What's the value?
0.1216.
1.9 divided by 0.2. Must be more than 1, right? 1.915 divided by 0.22233. Point.
5 divided
9.5.
8.21.
8.21. Right.
Yeah.
Next one. Kurtosis. This kurtosis.
Kurtosis.
This divided by this.
7.91.
7.91. Right. Besides the p-value, okay? Especially sample size large, p-value is not so reliable. So this person, Kim, suggested you to calculate these values. The value, Z1 and Z2. And how to interpret? And he is given sample size. Less than 50, Z1 or Z2 more than 1.96. Z1 or Z2 more than 1.96. Straight away data is not normal. Next, sample size 50 to 300. So this condition, Z1 more than 3.29, Z2 more than 3.29. These values. Are they more than 3.29?
Yes.
This value, are they more than 3.29?
Yeah.
Yes. Data is
So
not,
they are not normal.
right? For more than 300, normally for master's and PhD, we'll have this. It tells you first check whether extreme values or not. If extreme values, data is not normal. No extreme values. Then check the skewness and kurtosis. If either one of them, skewness more than 2, kurtosis more than 7, data is not normal. Data is not normal. If both are less than 2 and less than 7, data fairly normal. So most of the time for large sample data, we look into this, especially this. Most of the time for PhD masters, you may have more than 300. More than 300, most of the time, this p-value comes less than 0.05. So besides that, we can use this. Okay, what's the first point we'll check here? What's the first point to check? Now, what am I supposed to do here? Check for extreme value, right?
Yeah.
Extreme value. Now, look at my box plot. Are they extreme values?
Yeah.
Straight away, data is not normal.
Not normal.
Suppose you don't have extreme values. Don't have extreme values, right? Okay, skewness, you don't have extreme values. Suppose you know extreme values. Then you go down to next condition, skewness, and this one here. Skewness more than 2, kurtosis more than 7. Less than 2, less than 7. Is it less than 2 here? Skewness, is it less than 2?
Yes.
Kurtosis, is it more than less than 7?
Yes.
Then data is fairly normal. But based on this, we can't say that data is not normal, okay? So the other alternative you can use for large sample. Let's go back to the previous example. Okay, here. Right. What is sample size here? What is sample size?
108.
Right.
More than
Box
50.
plot. Box plot. Are there many outliers, extreme values? Any?
No.
No. So now we can also, instead of this p-value here, instead of this p-value, you also look at these values. So what is Z1 here? What is Z1?
Z1. Okay.
Is it less than what is Z1?
Professor,
Yeah.
Count.
I want to recognize you.
Yes. Yes.
I want to know
The Z1.
I want to know the extreme values. You know that sometimes our data have values. If we meet the extreme values, how can we do?
Okay. So you come back to that. You hold on first. I'll come back to that. So currently, skewness over this. How much is this?
That 1.16.
1.16. Okay. What is next value? This over this.
0.514.
0.154.
514.
0.514.
Yeah.
Okay. Now, look at the normality. What's the p-value now? I change the value. Okay, what's the p-value?
0.1.
Is it less than 0.05?
0.0.
Is it less than 0.05?
No.
Huh? I change the value. Now, what is it now?
It's larger.
Larger? 0.016.
Oh. Oh.
Maybe I change a bit. Okay.
Yeah. It's less.
Okay. Is it less than 0.05?
Yes.
Maybe data is not normal, right?
Yes.
Yes.
But here I don't have any major outliers, extreme values. Fine. And then this skewness and kurtosis values, this over this, this over this. These two, Z1 and Z2, are they less than these values? Are they less than this? Is Z1 less than the 1.16 is less, right? Also small, isn't it? The Z1 here, is it less than 3.29?
Yes, less.
Yeah.
This Z
less.
value, is it less than 3.29?
Yeah.
Right.
Yes.
For this sample size, even though p-value is less than 0.05, no extreme values. Now you can compare skewness, and kurtosis. Doesn't matter positive, negative. So these two values are less than 3.29. Data can still be said to be normally distributed. So not necessarily all the time, just strictly go to the p-value. Look at other conditions as well. Are we clear?
Yeah.
So in this class, assignment, whatever it is, when I say check for normality, and I give large sample. Supposing this is not met, you can also check this to justify the data is normal. Why is important? Data is normal, we can do parametric test. Otherwise, must do non-parametric test. Are we clear? Okay. Describing qualitative data. Very straightforward. Example 3. You want to describe job category. So for that, follow the yellow box, analyze, descriptive statistics, frequency. Right? Frequency. Analyze, descriptive statistics, and frequency. Which variable? Which variable?
Job
Category.
category.
Click inside. That's all. Click OK. Finish. Very straightforward. Right. So look at the results. That's a table. So the sample 33 bracket 30.6% high attendance, 36 bracket 33.3% are nurses, 39 36.1% are doctors. Right. Now the question is, why are there two columns? Are they the same value? These two columns are the same value? Percent, valid percent. Are they same value? Yes or no?
Yes,
No,
yes.
no.
No. 30.6, 30.6, 33, 33. Same values?
No.
Mm.
No.
Valid.
30.6, same,
Valid.
right?
They're the same.
Huh?
They're the same, right?
Same.
Yeah.
Same, right?
Yes.
The same means why two columns? Huh?
I have two values, two
Why?
meanings.
But the values are same, right?
Yeah.
So why must I give one more? No need, right? Okay, let's try another example. Try marital status. Why there are two columns? Frequency, select, click out, select marital, click in. That's all. Click OK.
Okay.
Right. Now check the two columns. Are they same or different?
Different.
Different. So why this column, especially the missing values? That means 6 people did not reveal their marital status. So check this now. Okay, marital, look at this. These 6 people did not tell their marital status.
Oh.
Comes like that, we say missing value. So that is missing. 6 of them did not disclose. So this percent based on the 108. This percent is based on the 102. So better report this than this. Then why have this? We want to know this. How many percent are missing? we don't want too much missing. Some say more than 10% missing is not good, right? So percent is based on total. Valid percent is based on complete cases, right? So bear in mind. Very straightforward, right? Okay. Exercise. Before that done. For these variables, you're going to do the 5-point summary. 3 variables. Do a 5-point summary first for these variables only. Okay, for 3 variables.
We don't have the data. How?
Do you have data? I sent you email.
Oh, okay.
The email.
Oh, which email is it? I'm not sure if I received it.
First, I send the notes, right? After
Okay,
that,
let me check.
I send the data.
Okay. Yeah. So we are going to use SPSS.
Yeah. I want these 3.
Which
Yeah.
variable?
Yeah. Okay, somebody asked me a question just now. What was this? Outliers, right? Extreme values. Okay, how to handle extreme values? All right. Okay, just now, triglyceride, okay, TG, the extreme values. So what I'll do, highlight, right click your mouse, right click, and descending. Highlight, right click, descending. Now these are the values very high. So check the people, check the doctors, triglyceride 9, is it possible or not? They say it's not possible. People cannot have 9, supposing. Then what do you do? You can remove it. Remove it and run again. Right? And remove the extreme values. Let's see what happens. Check the box plot. The outliers still there. And normality is not normal. Divide Z1 and Z2 is very high. So again, we ask them again. These values, are they possible? Are there many people having this value? Supposing the doctor say, not many, I may want to remove this. I'm planning for normal people. Explore again. Normality is not there. Box plot. Only 2 outliers. Then check the ratio. This over this, this over this. Second one, we know this over this less than 3.8229. What about this over this? 0.88 or 0.2? How much is this? Is it more than 3.29?
Yeah, more than.
How much is that?
3.63.
3 points, not too bad, right? This is clearly less than 3.29. It's not too bad. For this data, we can assume data is fairly normal. Remember, I did not do myself. I got the expert's opinion. Is it okay to drop the 9 cases? Then the data is quite symmetrical, not very. Skewness is symmetrical, right? Less than this. So the data is symmetrical. This over this slightly more than 3.29. Toss is clearly less than 3.29. Okay, justified. Data is fairly normal because the 2 cases, they're not extreme, just outliers. What do you think if I remove this? What do you think if I remove this, what will happen? Let's try. Remove the 2 cases. Okay, these 2 are 2 extreme values, these 3 cases. Run again. Sometimes this is called data cleaning. Okay, there are no outliers. P-value still not significant. Now, second one is clear, less than 3.29. What about the first one? This divided by this, how much is that? What?
3.28.
3.28.
28.
Is it less than 3.29?
Yeah.
Yeah. So in practice, we do that, but you must document this, must tell in the data for the variable TG, 9 cases were in the outliers, extreme values, they were removed. So finally, only 96 cases. These 96 cases are fairly normal. Then you go here. Okay. Some extreme values, sometimes we have to drop them because they're not very common. Are we clear? So it's not necessarily always look at the p-value. You can check this guideline, use this guideline as well. For small sample, Z1, Z2, moderate sample. For anything more than 3,000, we go for the 2 and 7. Okay? Okay. Can I do this? 5-point summary first one, do that first. Do this and take a break. I see you at 5 o'clock.
Hello, Professor.
Hello, class. Hello.
Hi, Professor.
Are you done? Have you finished? Have you finished?
Okay.
Have you finished? Yes or no?
Finish the exercise now?
Yeah.
No,
We
I
even
didn't install the software.
Install software now.
Ah, okay.
Okay, finish it.
I did it, but I'm not sure if it's correct because I'm not familiar with the software.
You already done it?
I finished, but I'm not sure if it's correct because I'm not familiar with the software.
Okay. So let me show you then. To analyze, descriptive, explore. Now the variable is BMI. In fact, I do all the variables together. BMI, DBP, and age. It's not necessary, you must do one at a time. The plots, numericity. Okay. Right, this for BMI, BP, and age. So for all the three variables, that's a mean, this standard deviation, that's a median, and this is skewness. Still within plus or minus 1. Diastolic, mean, plus or minus standard deviation, median, and skewness. Within plus or minus 1. Last one, age, mean, standard deviation, median, and skewness. Still within plus or minus 1. Next, the distributed normal. See all the variables, the p-value is less than 0.05. All are not normal. Let's look at the box plots. BMI, no extreme, no outliers. This is for diastolic, no outliers, extreme values. For age, also no outliers, extreme values. Now back to test of normality. You can see all the p-values are less than 0.05. Therefore, they are not normal. So let's check the symmetry by, normality by skewness. Z1, that is Z1, clearly less than 3.29. This also less than 3.29. Here we can see, I think also less than 3.29. Also less than 3.29. Clearly less than 3.29, less than 3.29. So even though the p-values for test of normality are all less than 0.05, based on Z1 and Z2 values, the data is fairly normal. All right, so we can go into this. Okay. Now for qualitative variables, these three, again, straightforward. All can be done simultaneously. Descriptive, frequencies, remove this. So bring physical activity, PA, physical activity, MC, medical leave taken, and movie. I can do all in one go. Click OK. So these are the frequencies and percentages. Okay, putting them together. If you're writing a thesis, with chapter 4, this is summarize over there. Let me take the word file.
Emily?
So mostly this can be said, number one, demographic characteristics. Okay. So normally, insert table, insert table. Say we take that number, variable, frequency, percentage. Your mean plus minus standard deviation plus 100. Okay, what variables you have? Let's start with qualitative characteristics. So you'll do for everything. All the demographics. Analyze, descriptive, frequencies. Let me reset. So gender, job category, years of service, marital status. Okay, until here, these are demographic characteristics. Right? To tell the reader who your respondents were. Okay? So this for gender. Gender, male, female. Frequency, 7 bracket 52.8%. 1 bracket 47.2%. Next variable, job category. Gender. Nurse. The doctor. Three, 30.6. 36. One. So continue. Years of service, marital status, continue. So we describe all the qualitative variables by frequency. Next, I'm going to quantitative variables. Any questions so far? Example, marital, huh? Okay, marital status. Go. Married. Once married. So numbers are same, 27. Next, 63, 12. But percentages I'll take from varied percent because some are missing. So 26.5. Next is 58.26.5, 61.8. Next one, 11.8%. Okay. Demographic characteristics, gender, they're all qualitative variables. All right. Let's go to quantitative variables. Analyze, descriptive, explore. Let's select the variables. Age is quantitative. Height, weight, quantitative. And BMI. Okay, these are demographic characteristics, the measurements. Okay, let's take this. Age, weight, height, and BMI. Take the plots, multi-plot. Okay. Right. So first one is age. Age, I put under mean plus or minus standard deviation. So they are quantitative variables. So mean is 41.56. And the standard deviation is 5.41. Next variable, height. Height is 1.65 plus minus 0.04. Weight 77.38 plus minus standard deviation 15.20. Age, this is height. Okay, that's enough. Only BMI. The height and weight is there, and only BMI. Right. So before this, write something. You can't just leave a table alone. Demographic. Okay. And describe the table. In terms of gender. Okay, start away among the respondents. 52.8% for females. .6% for attendance. 53.3% nurses. All right. So here's marital status. Majority. Majority 100%. Majority fucking marital status 61.8%. Right. So something I haven't added here. So we'll add here. Okay, describing the qualitative variables. Quantitative variables, the mean, age, was the mean age right? All the demographic characteristics must be one table. Don't do one table for gender, one for this, no need. And no need for graphs. You're talking about demographic characteristics, tell how many respondents, and showing over here, and just briefly describe characteristics. That's all. Don't put bar chart, pie chart, all this, not necessary. Okay, this is a template example, how I want the data to be presented.
Sir,
Yeah,
is this our homework?
I'm going to give a homework now. After this, I'm going to give a homework.
Okay.
The same data, the homework is the disease health characteristics. Health characteristics. DM, diabetes. Written there, right? DM's diabetes. Look at the data. DM for diabetes, right? Maybe instead of DM, maybe I change it, right? It's supposed to write in full. Diabetes, okay. For this data. Oops. MC, take an MC. All right. Other things are SPP, triglyceride. Okay. Okay, this is the homework. Homework 2. So I've done this, table 1 for demographic characteristics. Same data set. I've taken this health characteristics, how healthy they are. Okay, health characteristics. So it's the same table. So these are the variables. Okay, these are variables. As you can see, all these are qualitative. Below that is quantitative. Okay. Below this. All right. All this qualitative. So same like this. These three are qualitative. Will go here. And you must write something in between. Exactly same way. I describe something. So prepare the table. So there's a heading. And table there. Write something in between. Okay, this homework 2. So it starts from here. This is just tell you what data. These are the variables to consider. And below that homework. Don't have to give this. All these go into the table. Did you understood? Just follow the this for healthcare.
What is the
Yeah.
What is the deadline for this homework?
Okay, Thursday.
Thursday? Okay, thanks.
All right. I just want to show one. Look at triglyceride. You know, triglyceride was not normally distributed. Okay, triglyceride will report mean or median. All these fall report in median because they are fairly mean, so they are fairly normal. What about triglyceride? Let's look at triglyceride. You know, here's some data. Oh, clear some data. I go back to get original data. Hold on, huh? Okay, now look at the analysis. We're going to do for TG. Okay, TG. Right. Analyze. Descriptive statistics. Explore. Variable TG. Plots. Normality. Okay. TG, you can see heavily skewed. 1.9 over this, definitely more than 3.29. It's not normally distributed, and major outliers or extreme values. Therefore, TG is not normally distributed. So when it's not normally distributed, don't report mean. Report median, and interquartile range. It's normally distributed mean and standard deviation. Since it's not normally distributed, median and interquartile range. Right? For example, in completing this table, let me remove all this. Suppose I'm doing TG, it's one of the examples. TG. Right? So there's a TG here, track this right. Track this right. Okay. So I won't report mean and median because data is skewed and it's not normally distributed. So what I report is median. The median is 2.19.
0.19.
Okay, 2.19 bracket, don't plus or minus 1.66.
1.66.
Right? But the heading is mean and standard deviation. Then what do you do? Put an asterisk sign, put a footnote, median, and IQR. Just to differentiate. Right? Median and IQR. So earlier must be here. Earlier, we didn't change it all plus or minus 1, plus or minus, because they were distributed normal. So when it's not distributed normal, we put the median and interquartile range followed by the footnote. Right? So it comes like this. You're going to report like that. So I check all this first, whether all the normality assumption, symmetry, all this accepted or not. If not, you report median and interquartile range. All right, that's all. Okay, this is homework 2. These are the variables. Heading, health characteristics. So table 2, health characteristics. Fill up all the values here and describe, as I did earlier. Okay, you're going to describe this. That is your homework 2. Any questions? Any questions?
No.
No.
Anybody
No.
assess SPSS? Problem with SPSS? No problem? Right. So let me continue the work. As soon as you submit this, you can't finish today by Thursday. Remember, it's not assignment, it's your homework. Later, when I give you assignment, I expect all these steps to be there. Right? So you must tell first who are your respondents. After that, maybe we do some other analysis, regression, general linear model. But first, you must tell who your respondents were. So in your thesis, chapter 4, first table will be this. First table will be describing your respondents. Okay? Enough for today?
Okay.
All right. So you can start
Can
working
you
on it.
send us the document, Professor?
Say again?
Can you send us this document?
For this document. Okay, I deleted some. Let me see, I recall, all right?
Professor, you mean that we need to signature?
Send what?
You mean that we need sign our names on this document?
Yeah, you must write your names. Right?
Send you the email or to the Times?
To my email.
Okay.
All right. So this is the example, and that's your homework, right? I send both files. Okay?
Okay.
All right. So,
Professor,
yeah.
will you upload the video record on the website?
Yeah, I'll do that.
Okay, because I need to review it. Thanks.
Okay. Any other questions? Any other questions? All right.
I have one more question. Is it possible to extend the deadline to this Friday? Because I feel like I need like a couple of days to review on it and work on the SPSS system.
Okay then, Friday.
Yes.
Okay. Friday, okay?
Oh, yeah.
If you do it as soon as you do it, but you can't latest by Friday. Okay?
Okay.
All right. So this I expect here. Right. So I'm going to send this now. You can continue filling up. So this is my example. And this is your homework. Right? And that's the variables. Do exactly the same. All right. Okay. Stop here for today. This is homework 2. All right, no question. We stop here. See you next week. All right.
Okay.
Bye,
see you.
sir.
If there be anything, I'll send you. Bye.
Bye. 他的标准年龄啊，因为它是一个经济。